Good morning, 3C. Today is 19th of June. Today is Friday, the last day of HBL. So for today, we will go through yesterday's activity, which is activity 1.5, as well as the page 11 of SIN. And today we'll be exposing you to more questions on MANEX and the properties of MANEX. And just make sure that you have finished all the HBL work from April and all the way for these 2 weeks of HBL as well. And then when you come back, you're coming back with everything done. Okay, so if you have gone through the video yesterday in the SLS lesson on freely suspended MANEX, we have realized that whether is it a freely suspended magnet or whether it is a freely floating magnet, when it comes to a rest, it will always point in the same direction as a magnetic compass, which is in the north-south direction. Okay, no matter how you spin it, if you purposely change it, it will always turn back to the same direction, which is called the north-south direction. Right, later on we'll be covering on what's important to take note, and especially for the exercise one, it's very important for you to know how to explain clearly why certain observations are seen. Okay, so I won't go through all the instructions because you're not doing it. So basically what happens that you hang a magnet using a string, which you saw in the video. You let it swing until it stops, and you look at which direction it's pointing at. You push it again, let it swing, and then you come back to a rest, and you're just observing if the magnet came back pointing the same direction as the first time. So because we know that magnets will always point as in all 3D hanging magnets will always point in the same direction, which is the north-south direction. So it doesn't matter how many times you spin or where you do it, it will always point in the same direction, the north-south direction. So does the magnet point in the same direction as the first time? Answer is yes. Okay, so if you watch the video, you should have known this answer. Again, we'll come back to school and we'll do it in school in real life to have that you have a look at it so as to be more convincing. Okay, so let's go to page 2. So same thing, instead of hanging a magnet using a string and let it spin freely and come to a rest, we can also put a magnet on water, making it float. So we actually put a styrofoam board. Again, we'll do this when we come back to school to let you see. So I put the bar magnet on a plastic plate, I let it float, and I'm make sure I put it away from other magnets. Okay, I spin the plastic plate a little, I let it turn until it comes to a rest, and they want you to observe the direction that the magnet is pointing, that is floating. Is it the same? It is the same because all freely hanging magnet or freely floating magnet will always point in the same direction, what we call the north-south direction. Of course, a compass, if I take it away from all the magnets, a compass always point in the north-south direction. So yes, it points in the same direction as the other two. So compass works in the same way as your freely suspended magnet. Actually, the needle inside the compass is actually a magnet. It is actually being balanced very well, and it can actually spin freely. So because the magnet, it will always point in the same direction when at rest. When it comes to a stop, it's always in a north-south direction. Okay, for observations, this one, I know some of you done, I know Shen done, I know Kezia done. Don't need to do this part yet. I will come back to school, we will see it for real, in real life, and then we'll do this part together. But I want you to do the conclusion part. A freely suspended magnet always points in the north-south direction. Please use capital N and capital S and make sure there's a hyphen between the north and the south. Okay, so it's in the north-south direction. Make sure you put a capital N and a capital S and a hyphen in between. All right, let's go to exercise 1. This is where I need to be more clear on this. Okay, I have two types of metals, X and Y. Two objects over here made of metal, X and Y. So they are both metal, we know, because they are all classified under metal objects. One is non-magnetic, one is magnetic. So X is non-magnetic, Y is magnetic. What happens when a magnet is brought near them? Will magnet interact with non-magnetic material? No. So for example, if you have a plastic bottle, you put a magnet close to it, nothing happens. So for non-magnetic material, there will be no interaction. Don't say nothing happens lah. There will be no interactions. Okay, because non-magnetic objects, non-magnetic materials, they will not be attracted, they will not be repelled by the magnet. However, for magnetic objects, they will be attracted. Okay, they will be attracted by the magnet. They will be attracted by the magnet. Yeah. Okay, so you need to be very clear how the interactions of magnets are. You need to know the interaction between a magnet and a non-magnetic object, magnet and a magnetic object, and between magnets. Okay, these are the three that we will be focusing on when we come back to school. Okay, so we know that magnet won't interact with a non-magnetic object. We know magnet will attract a magnetic object. So what will happen? Um, let's look at each one and let's see correct or wrong. Magnet will repel X. No, it will not repel X. Okay, because there's no interaction. Magnet will attract X. Magnet will not attract X. Magnet will attract Y, correct, because it's magnetic, but not X, correct, because there's no interaction. Magnet will repel X. No, it will not attract nor repel X. So answer is 3. Okay, so next one, I have an object in my hand. I bring it near to one end of the suspended magnet and I realize it repels, or both of them repel each other. What can you conclude about the object and why? Okay, you now is the time to bring back to what I said just now, the interaction between magnets and non-magnetic material, the interaction between magnets and magnetic materials, and the interaction between magnets. You realize the only interaction that involves repulsion is when a magnet interact with a magnet. Okay, when a magnet is placed near a magnet, two things can happen. It can either attract or repel. Okay, so let's put it down in words so they are more clear. Okay, so interactions. Okay, yeah, interactions between magnets. Okay, interactions between magnets. So if I bring a magnet close to each other, what will happen? Okay, so like what I said, interaction between magnets, two things can happen. Number one, the magnets can attract each other. So let's write it down. Attraction can happen, or on the other hand, you can have repulsion. So when two magnets are placed together, you can have either attraction or repulsion, and only in certain scenarios each of them will happen. So in order for attraction to take place, the unlike pole must be facing each other. Okay, so for attraction to take place, the unlike pole, like the north and south and north, must be facing each other, then they will attract. Okay, but for repulsion, it's the other way around. Okay, for repulsion, what happens is that the like poles are facing each other. Okay, so this is how magnets will interact. So when I put a magnet close to each other, two things can happen: either attract or repel. When you see attraction, it means the unlike poles are facing each other. When you see repulsion, it means the like poles are facing each other. Okay, and the only time repulsion can occur is between interaction between magnets. Okay, if there's a magnet and a magnetic object, there's no repulsion, there's only attraction. Okay, so when you see the word repel, it tells you a lot about the object itself, that the object is actually a magnet. Okay, so what can you conclude about the object? It is a magnet. And how do you know? Okay, because okay, this is the full answer. Okay, since the object is able to repel, okay, since the object and the magnet repel each other, okay, so since the object and the magnet repel each other, means that the like poles are facing each other. Okay, the like poles are facing each other. Okay, if the like poles are facing each other, means the objects have magnetic poles. And when the object have magnetic poles, it means that the object is a magnet, because only magnets have magnetic poles like north and south pole. Okay, hold on. So the object has magnetic poles, making it a magnet. Okay, this is the most complete answer that I can give you. Okay, so let's make sure you can see. I will use something like that. Okay, so this is the answer. Since I know they repel, means the light poles are facing each other, means that the object has a magnetic pole or has magnetic pole, so it is a magnet. So what can you conclude about object? It is a magnet because since both of them repel each other, the light poles are facing each other. Because repel means the light poles are facing each other. So if the light poles are facing each other, means the object itself have magnetic poles, making it a magnet. Okay, that's why it is a magnet. Okay, this is the most complete answer that you should write. Of course, most of you didn't write this way, but this you should learn to write this way as well. Okay, so take time to copy. Now we'll go on to the next part. Okay, this is your SIN. Quite straightforward after going through this lesson. So I'm just gonna go quickly. Make sure that every time you write north and south pole, it is in capital letters. Okay, so over here, just gonna write it out. Okay. Alright, no background. Okay, so a freely suspended magnet always points in the north-south direction. Okay, a freely suspended magnet always points in the north-south direction. When it comes to a rest, it must come to a rest. Okay, or if not, it keeps spinning. Okay, again, make sure you write the capital N and capital S. Okay, so next one. Okay, the Earth itself is a giant magnet. The magnetic effect of the Earth interacts with the freely suspended magnet, causing it to point in the north-south direction. Okay, so basically it's just emphasizing which direction it's pointing at. Okay, the pole of the magnet that points towards the north is called the north pole, and the pole of the magnet that points towards the south is called the south pole. Right? Okay, so you will realize this diagram. This is a compass, this is a free suspended magnet. When they are at rest, both of them will point in the same direction, the north south direction. You cannot say south north, it has to be north first then south. Okay, so I want you to perhaps write this down. They are the pointing in the same direction. Okay, let me just change the size. Okay, so I highlighted this because to show you that they are all pointing in the same direction. Okay, let's make this in capital letter. Okay, pointing in the same direction. Alright, so let's go on. A compass works in the same way as a freely suspended magnet because it is built like that. The needle in the compass is a magnet and it is freely suspended, balancing on a point. So the needle is a freely suspended magnet. Okay, the needle in the compass is a freely suspended magnet. It points again to the north-south direction. Make sure you have a hyphen in between. Alright. Okay, so this is your homework today. Make sure you get all the corrections done or the work done on your activity book as well as your SIN. Okay, so for today, the second part of the lesson will be just go through a few more questions, and after that, your homework will be to just make sure that everything that you have done for the April HBL as well as the June HBL are all completed, so that you can come to school fresh. Okay, for your test that's coming up, like same as maths, the test I cannot push it to week 5. Your test will be happening next week on week 4. However, we'll put it right at the end. I will do it on Thursday. Okay, I will do it on Thursday double period. It will cover all the way to materials. Okay, so take the time to revise through from classification all the way to materials. Make sure you do some questions to help you understand, and then you will sit for a test on Thursday and it is counted. All right, so with that, I'll see you when you come back to school.